Welcome. We're on to exciting things. We're going to learn to set up a linear system to model a real-world situation. And there's generally a thought process that we need to go through when we're doing this. If we don't take the time to properly identify variables, the constraints, and writing the equations properly, our solution technique is not going to matter. We've got to make sure that everything is set up properly before we try to do it. Okay, so step one, whenever we try to solve a model or set up a system of equations to model a real-world situation, the first thing we need to decide on are the variables. So we need to define variables. Now every system is going to have a different number of variables. You could have 2 variables, you could have 10 variables, you could have 100 variables. But let's just say we'll keep this example really simple here. What we want to do when we define variables is say distinctly, let x equal, or let whatever we want to call the variables. Let's just say x1. Let x1 equal the, maybe we have a company that wants to purchase iPads and Android tablets for its employees. So we need to figure out how many of each to purchase. So we'll just say that this is going to be the number of iPads to purchase. Okay. We don't know what the answer is yet. That's why we say let x1 represent that. We're going to want to solve and figure out what value x1 should be. x2, okay, so if we have 2 types of devices, maybe this is the number of Android tablets to purchase. And now once we have variables defined, we need to decide on what are we going to be writing equations for. So in practice, before you even start writing equations, you first identify constraints. Okay, identify constraints on your variables. And what we mean by this is there are some statements, written statements, that express what limitations you have on the number of devices you're going to purchase. So you're looking for that kind of information. So let's just say that we read through a set of constraints and we find out that we need a total of 100 devices. Okay, so maybe that's what we need. And also, we know that we have a budget, right? So we'll say that we have a budget of, I don't know, we'll just say $24,000. Okay, so these 2 things limit the values that x1 and x2 can be. First of all, we don't want more than 100 devices or fewer than 100 devices. We want 100 devices. And we can't just buy all iPads because maybe that's going to be more costly than the $24,000 that we're allocated. So we're going to try to meet these exactly. Right now, yeah, we could spend less than $24,000, but that's what we have budgeted for it. So we're going to try to use it up as closely as we can. So let's just say that I give you some information, and then an iPad the company was able to purchase for $300 per iPad. And let's just say that the Androids cost $200 per tablet. Okay, so combining these 2 things now, I am ready to write some equations. So that's step 3. Convert verbal constraints. So we've stated those constraints in words, and we want to convert verbal constraints into equations. Okay, that's going to involve taking our variables and somehow arithmetically combining them to form the constraint. So to have a total of 100 devices, well, I'm going to purchase x1 iPads, x2 Androids. So in total, I'm going to purchase x1 plus x2 devices. Now I want the sum of the number of iPads plus the number of Androids. I need it to equal 100. So I just want to make sure that I have 100 devices. So iPad devices plus Android devices has to equal 100. So that takes care of this constraint here. I've just converted that into equation form. The next thing I need to do is satisfy my budget constraint. Okay, well, how much am I going to spend on purchasing X1 iPads? Well, if I purchase X1 iPads, they're each going to cost me $300. So that means that if I purchase 10 iPads, that would cost me $3,000, or 300 times 10. So this is $300 per iPad times how many iPads we get. The cost of purchasing X2 Androids, each of them is going to cost me $200. So if I had, for example, if X2 was 10, $200 per Android times 10 Androids would be $2,000. Now, the costs are going to get combined, right? We're going to spend 300 X1 for the iPads, 200 times X2 for the Androids, and we are limited by a budget. So we're going to say equals 24,000. Now, yes, in practice, it's less than or equal to 24,000, but we're not really equipped to solve problems like that with the method that we're using. So we're going to say we want the constraints to be met exactly. So meet exactly. Now, we've gone through the process. We've identified what the variables are. We've identified the constraints. We have the equations. It's very clear what we're trying to figure out now. And now and only now should we move on to step 4, which is to solve the system. And so at this point, I'm going to use my technology and get 100 for the first equation, 300, 200, 24,000 for the second equation. And okay, so we're solving for X1, X2 coefficients, and then the constants. And when I perform my Gaussian elimination, what I'm going to come up with is 1, 0. I've already solved this, but you can use the Wolfram Alpha app or whatever technology you want to solve this. And this is going to be 0, 1, 60, which tells me I have a unique solution. Each row has a pivot of 1 in one of the columns. So this means that X1 equals 40, X2 equals 60, and I've solved the problem. But I'm not done, because that just solved the system. That didn't address what the solution was. So now we have to interpret our solution, right? So what this means is that the company should purchase or should buy 40 iPads and 60 Android tabs. And now we're done. We've gone through the entire progression of solving a system of linear equations, modeling it to a real-world problem, going through the whole sequence of the solution process.